In this video, we are going to be looking at linear models or linear functions. When we see this word model, often that just tells us that we're talking about an applied situation. In this video, we're going to be actually looking at a profit revenue cost application. So a linear model, this is just a linear equation, and you are probably familiar with this equation, y equals mx plus b. This is called the slope-intercept form. We could also write that linear function using function notation. It means the same thing. One important part of this slope-intercept form is the slope. Remember, slope is just a measure of how steep a line is. So when we've got a slope headed uphill, we know that our slope is positive. When we have a line headed downhill, we know our slope is negative. If our line is horizontal, then our slope is 0, and when our line is vertical, then our slope is undefined. So we usually just write the abbreviation UND for undefined. To find the slope, we're taking the change in our y, or if we're using a different variable, the change in our output over the change in our x, or again, if we're using a different variable, the change in our input. And this b here in our formula, this is our y-intercept. So when we go to graph, this is an upward sloping line, so it's going to have a positive slope, and it's going to go through this point right here, 0b. One of the things we're going to want to do is be able to build a linear model or build a function y equals mx plus b given information. The steps to doing this, first we need to figure out what sort of data points we're given, and we're going to write them as ordered pairs where we have the input in the first part, comma, the output. And then once we have our two ordered pairs, we're going to use that formula for the slope and find the slope. And then finally, we're going to plug in our slope into our equation and then plug in one of our points that we're given and solve for b. A shortened version of these steps is first we need to figure out what the points are, second we need to find the slope, third we need to find the equation. So just as a review here for how profit, revenue, and cost work, revenue always equals the price per item times the number of items. Our cost we can think of as broken down into two parts. It's our variable cost plus our fixed cost. Remember, our fixed costs are just the number part. The variable cost, this is the part with the x. When we have a linear cost, we can think of it as c equals mx plus b. The fixed cost is that b, and the variable cost is that mx. So the m is the marginal cost. This is the cost per item or the cost to produce one more. And the b, this is our fixed cost. Finally, our profit, this always equals revenue minus cost. And what I have over here is graphs of three functions that could be a profit, revenue, and cost. So this blue line, this is our cost, and I can tell it's a cost function because we start out at a point above that x-axis, whereas this green line, this looks more like a revenue function because revenue functions always go through the origin. When you sell 0 items, your revenue should be 0. That leaves us with the black line being our profit. Now remember that this point right here, this is a special point. This is called the break-even point. And this is where the revenue equals our cost, or when our profit equals 0. So those should line up at the same x value. Over in this region and in this region, this is where we actually have a profit, because our profit is bigger than 0, whereas over in this region and this region, this is where we have our loss. So remember, to find that break-even point, there's two ways that we can find it. One is we can solve revenue equals cost, or the second way we can find this is we can solve profit equals 0. Let's look at a specific example. So we're told a soft drink manufacturer can produce 5,000 cases of soda in a week at a total cost of $16,000 and 8,000 cases of soda at a total cost of $19,600. We're going to assume that the cost is a linear function, and we're going to use x as the number of cases of soda. What we're asked to do here is build the linear cost function and then identify the fixed costs and variable costs. So remember, 3 steps to finding a function. First thing we need to do is figure out what points we're given. So we have 2 data points here. We have actually before I start that, this is our goal. We're going to have c equals mx plus b. This is what we want to end up with. I'm using c for cost, and it's a function of the number of cases of soda. And this function here is a linear function. So the first thing we need to do is find those points, and my x variable, this part, this is my input, and my c variable, this is my output. So looking at this first value here, we're told that we have 5,000 cases of soda, so that's going to go in my input. At a total cost of $16,000, that's going to go in my output. The corresponding point for the second data point is 8,000, $19,600. So we've got 2 ordered pairs. The next thing we're going to do is we're going to find that slope. So remember, we're going to take the change in the output, or the change in our C, over the change in our input, the change in our X. So this is going to be 19,600 minus 16,000 over 8,000 minus 5,000, and this gives us 3,600 over 3,000, which is 1.20. So the last thing we need to do is find the equation. I currently know that that slope is 1.20, so I can put that into my formula here, 1.20x plus b, and then what I need to do is take one of my points here and plug it into my equation so I can solve for that value of b. So I'm going to use this point right here. The first value, that 5,000, that's my x, and the 16,000, that's my c. So I'm going to substitute the 5,000 for x and the 16,000 for my c. So I'm going to have 16,000 equals 1.20 times 5,000 plus b. If I multiply the 1.20 times the 5,000, I get 6,000. Moving the 6,000 over by subtracting on both sides, I get b equals 10,000. Remember, at the start, they asked us to identify the fixed costs and the variable costs. So we have 3 parts of our answer. My equation is 1.20x plus 10,000. My fixed costs are $10,000, and my variable costs are 1.20x, and again, that's in dollars. Next, we're going to write a sentence that interprets the slope. Now, in order to do this, I just want to remind you that to find the slope, we took our change in our C over our change in our X. So we had that 19,600 minus 16,000 over 8,000 minus 5,000. And we got 1.20. So I want to have the units that go with this, so let's make sure that we know what the units are. When we think about these two numbers here, those are our dollars for the cost of our producing our soda. So those are both in dollars. And these two numbers here, those are our cases of soda, so those represent cases. So our units, we're going to have $1.20 per case. To write a sentence, there's a couple ways that we can do this. One way is we know that we have a positive slope here, so this tells us our cost should be increasing. And so we could say that our cost is increasing by $1.20 per case. So a second way we can write this is we can say that the cost to produce one more case of soda, that's that idea with the marginal cost, is $1.20. A third way we could say it is the cost per case of soda is $1.20. In this next part, they're asking us to report the revenue and profit functions given that each case of soda is going to sell for $3.70. So this tells us our price. Now remember, revenue always equals price times quantity. If our price is $3.70, we're going to have 3.70, and remember, we used X as our quantity. So we're going to get R equals 3.70X. Another important formula that we know is profit is revenue minus cost. So our profit function is going to be that 3.70x minus my cost function, and my cost function was 1.20x plus 10,000. So if I distribute this negative sign over both terms, and notice that I had to put that cost function in parentheses because I had more than one term in my cost function. Distributing that negative sign, I'm going to have 3.70x minus 1.20x minus 10,000. So my profit function, 3.70 minus 1.20, that's 2.50 minus 10,000. So we've found our revenue function and our profit function. In the last part, we're asked to find the break-even. Now remember, in order to find the break-even point, we can do it in one of two ways. First way, we could solve R equals C, and the second way, we can solve profit equals 0. In this case, it's a little less work to solve it using profit equals 0. We know that 2.50x minus 10,000, this is my profit function. Set that equal to 0. I need to add 10,000 to both sides, and I get 2.50x equals 10,000. Divide by 2.50, and I get x equals 4,000. And remember, x is our cases of soda, so this would be cases of soda. So this is where that revenue function and our cost function meet up, or also where the profit function is 0. Now, another question that they could ask us is, what is the minimum number of cases that we should produce in order to make a profit? So this gives us a profit of 0. So in order to make a profit, we would have to have 4,001 cases.